Hello all. Today in this video we are going to understand about the structures in C++. We have learned about various data types used in C++. For example, integer, float, character, they are all different data types. But they are all built-in data types in C++. But there are other ways of creating data in C++. They are user-defined data types. We can have user-defined data types in C++. And structure is such a kind of a data type in C++. Suppose we have a class with several students and I want to categorize all the variables concerned with a particular student into one head. For example, we have a student and her marks, her address, her family income, her overall grade, all those things, if I have to categorize them together, there is a way, and that way is called as actually structures. Another example, let us take, suppose if we have an employee and his his name, his salary details, and all these different variables, they can also be categorized into under a single name. And this is where the structures come in picture in C++. So basically, structure is a convenient way to organize simple variables into a complex entity. Okay, so all the simple variables categorized together under a single name, and that is called as basically a structure. Now we will learn more about the structure. This is a general introduction to structure. So structures, they are a collection of two or more variables under a single name. Okay, as we said, one or two examples we took and we described about what it actually means. Suppose if I have a employee, so his salary is one variable, his name is another variable, his department is one variable, and all these things can be clubbed together under a single name. And structure is such a collection of two or more variables which can be categorized together. Okay, so these are used when it makes sense to associate variables. We said that there is a reason for categorizing them in under a single name, right? So when it makes sense to associate variables, structures can be used. And another important thing is that we said that so different more than one variables categorized together are called as structures. Okay, and then the thing is, it is not necessary that all the variables has to be a particular type. No, one variable can be integer, another variable can be a float type. Okay, so different types of variables can be combined together under a structure. And each item in the structure or each variable or each item in the structure is called as the member of the structure. We said different data types can be associated together, which means that each data type or each variable there can be considered as the member of the structure. Now we said that this is not a built-in data type in C++, it is a user-defined data type. We define a structure in a way which we like. So this is a user-defined data type. Now we'll see how a structure is defined or what is the syntax of a structure definition. So first thing is we are going to define a structure. Okay. This is an example of a structure definition. Okay, so here I've written struct, the name, then I opened the curly braces, then in that several variables are there, several data are there. Okay, now we'll see each one in detail. The first word which we used, struct, that is struct, is actually the keyword used for defining a structure. Okay, from this you understand that this is basically a structure. Whole this thing, the whole thing together is actually the structure definition of a structure. So when I use the name struct or when I use the keyword struct I understand, or we come to understand that this is a structure. Okay, so any structured definition will start with the keyword struct. Okay, next thing is we have a name for the particular structure. Here, the struct is with the keyword I have started defining a structure, and then I have to give a name for the structure. Okay, and that name is given here. It can be anything, something related to our logically reasonable name, any name you can use. So here I am used name as the name of the structure. Okay, so struct, the name of the structure. Then you open the curly braces, okay, and you understand that all the structure members, these are the structure members, and all the structure members are written within this braces. So after the keyword struct and the name of the structure, I open a curly bracket, or I open a braces, and all the structure members are written within this braces. Okay, now you have to understand that finally the curly brace, closing of the braces will be ended up with a semicolon. So the semicolon actually make us understand this is the termination of the structure definition. Okay, with the semicolon we understand that the structure definition is terminated. Now about the structure variables, structure members. So here there are three members in the structure, and the first member's name is name1, second member is name2, and the third member is name3. And as we said earlier, all of them are not of the same data type. Two are integer type and the other one is a float variable. Okay, so this is about the syntax of a structure definition. Thus a structure starts with the struct keyword, then the name, then braces are opened, and then all the structure members are written within that, and the braces is closed with a semicolon. Now we are going to write a program and then understand the different features of a structure. So here I am going to present before you a program which actually represents the items of a company, and this is a company which produces some mechanical devices or some gadgets. Okay, so we are going to define here the structure members the different parameters related to the gadget. So this is the program. So as we usually write, we started with hash include iostream. So header file is loaded, and then you can use using namespace std. Okay. Then after that, the first part here, what I've done is I have defined the structure. And here, when you define a structure, we have to use the keyword struct. So that is now clear. So struct is used. Then I have to give the name for the structure. So here, based on this is a part of a machinery. So I give the part as the name of the struct. Okay. So struct part, remember this part is actually the name of the structure which I am using here. So struct part the name is given, and then braces opened. Then I defined three structure members, and the first structure member is integer type. So the name of the structure member is model number. So basically it represents the gadget's model number, and the second variable is part number. Second one is the number of the part. Okay, so that is the part number is another structure member, and then that is also of integer type. And the third one is actually the cost of the gadget, and that cost basically we know that it is need not be an integer, so I defined it as a float value. Okay, so these are the three structure members. Then the structure definition is over, and then the braces is actually then followed by a semicolon. Okay, next is we are coming into the main program. So the definition of a structure is written before the main part of the program. So I define here it in this way before the main program. Now the main program starts, that is integer main bracket open, then the curly braces open. Okay, then first now the thing is I am going to, so struct is a particularly, we understand that the struct is defined. Okay, so we have defined the structure named part. Now what we are going to do in the next thing is we define a variable under this struct. Okay, so remember part was the name of the structure, and then I am going here, I have defined part 1, which means that actually the part 1 is a variable under this structure. So we said that actually structure is a variable data type, we said. So normally when you define a data, for example, I normally use, say, I am going to define a variable, say x, and that is an integer type. How will you define int x? That is how we define the variable, right? So in the same way, here actually part in the place of int, now actually the part comes into the picture, because structure is a variable. We said that structure is a particular data type, which means that structure, when as a integer is also a data type. So as you define an integer, then as you as you define an integer data type, you can also define a structure data type. So instead of this int x, I am using here part x. Okay, so here the structure name is part. So I say that the structure, similarly as I use int, instead of that I use the part here. Okay, part is a variable data type, or here it has, I have defined a data type which is known as part. Okay, so I can use, as we use int float and all, I use here the name of the structure. So this is basically, we can consider here as a data type. And now, and this is the variable under this data. Okay, and part 1 is a variable under this structure. So I say that I first write the name of the part, and then I write the what is the variable of the what is the variable name of the variable which comes, and that is part 1 is the variable. Okay, you have to understand that part 1 is called the variable of the structure part. Okay, remember part 1 here is the variable of the structure part. So now it defines, one thing I forgot to tell you, that is when you define the structure here, this was the definition, and when you define the structure, we say we understand that the program understand there is a user defined data type called a part, or there is a structure whose name is part, and it contains three structure members, but it doesn't reserve a space. When we know that when you use int or float with a variable, then the space for this variable is actually allocated in the memory. But when you define a structure, actually these space for this model number, part number, and cost, that is, we know that 2 byte or 4 byte, these are reserved in the memory. So this, when you define a structure, this memory space allocation is not done. That is, when you define a structure in the definition part, the space required for the variables are not actually allocated, but that is allocated only in this part here. So when you define here, what I'm again repeating that here I define a variable called part1 under the structure part. Okay, so but when I do this, actually it reserves the space in the memory for the part 1. Part 1 actually contains three members. Actually it holds 3 members. That is part model number, part number, and cost. Okay. So this so I again repeat that part 1 is actually a variable of the structure part, and when you do this, when you define this, actually the part 1 also has these 3 parameters like model number, part number, and the cost. So these 3, the space for these three numbers, that is model number, part number, and cost number, which we have defined in the structure definition, will be then reserved during this definition time. Okay, when I write part 1, that is the name of the structure and then the variable under the structure, during that time when I define so, the members under this structure, the space for the members under the structures will be reserved. Okay, I hope you understood. Okay, now we have to see that once a structure variable has been defined, how its members can be accessed. Okay, here the structure variable has been defined and the structure variable is part 1. Okay, now the members under the structure variable has to be defined, and the members here are which one? Model number, part number and cost. These are the members of this structure variable. Okay, structure is part, and part 1 is the variable of the structure part, and then the structure members under this part 1 are model number, part number and cost. Okay, and that how it is defined. First one, we said part 1 is a variable of the structure part. Now this dot operator is used to access a member of the variable. Okay, so we said that part 1 is a variable, and a member of the variable. Which are the variables? Members of the variables. The members of the variables, we know that they are model number, part number and cost. So if we want to define the member under this variable part 1, we have to define it using we have to write a dot between them. A dot operator is basically used to access a member of the variable. So here there are 3 members for this variable part 1, and they are defined as part 1 dot model number, part 1 dot part number, part 1 dot cost. And these are the 3 variables. We define these as 6244, 373 and 300. Okay, then next step you are familiar with, when I use cout along with model and part 1 dot model number. So now I call these 3 variables are part 1 dot model number, part 1 dot part number and part 1 dot cost. It is defined as 6244, 373 and 300, and that will be when I finally run this program, and after execution what will be there on the screen is their part number 6244 and 373 and 300 will be printed on the screen. So this is how this program works, and this is the basic feature of a structure. I hope you understood well, and if you have any doubts, please comment. Thank you very much.